So welcome to biology tutoring today. So we're going to be continuing off of genetics such as last week and going more in depth regarding like diseases and also a small experiment that you can try.
So for the quick review, genesis is the study on how living organisms such as people inherit traits from their parents. It shapes our health, appearance, and personality. Genes are made up of DNA and are wrapped together in chromosomes. Every human has 23 pairs of chromosomes, which make 46. Half of the genes come from their mother and the other half the father. A genetic disorder happens when genes have an issue with their code or when the child inherits it from their parents.
So for a small experiment, you can try taking a strawberry's DNA, which you can see in the right picture. That's the strawberry's DNA on top of the liquid. So regarding this, you'll need a couple materials such as water, salt, dish soap, some strawberries, a Ziploc bag and rubbing alcohol, and utensils to mix it with. So first, you want to make the extraction liquid, which you can see on the right in the small video, where you mix the water, salt, and dish soap together. Then, after taking the stems off your strawberries, you can mash them all up in the Ziploc bag, which then begins the process of breaking open the cells and releasing the strawberry's DNA. Afterwards, take 3 spoons of the extraction liquid and put it in the Ziploc bag and mix it around. After, strain the combined mixture and pour in the rubbing alcohol. And after waiting for a little bit, you'll be able to see a separate film rise to the top, and you can scrape it off to place in a separate bowl, which is the strawberry's DNA.
Genetic is 1, Parkinson's disease. The loss of nerve cells in the substantia nigra, a part of the brain that is critical to the production of dopamine, causes Parkinson's disease. Parkinson's disease is a progressive nervous system disease that can affect movements. Symptoms can include tremors, stiffness, slowing of movement, speech changes, and etc. Genetic disorders 2, Huntington's disease. A brain disorder, Huntington's disease is caused by a single defective gene on the chromosome 4, one of the 23 human chromosomes that carry the entire genetic code. This defect is dominant, meaning that if inherited from parents, the child will eventually develop this disease. Huntington's disease causes breakdown of nerve cells in the brain. This results in hampering of a person's movement, cognitive, and psychiatric abilities. Genetic disorders 3, sickle cell anemia. Sickle cell anemia is an inherited disorder where the child inherits one set from the mother and one set from the father. This cell disease affects the shape of red blood cells, which carry oxygen. These sickle cells become rigid and can slow or block out blood flow. For most people, there is no cure, but treatment can help relieve pain.
Next, we're going to be talking about Down syndrome. So Down syndrome is a genetic disorder that is caused by the presence of an extra chromosome, also known as non-disjunction. Even though people with Down syndrome might act and look similar, each person has different abilities. People with Down syndrome usually have an IQ, which is a measure of intelligence, in the middle to moderately low range and are slower to speak than other children. Some common physical features of Down syndrome include, but are not limited to, are a flattened face, almond-shaped eyes that slant up, and a short neck.
These are our works cited. Thank you so much for attending this week's tutoring.
Hello, physics students. This is Team Physics back at it for week 12. And today, since we finished our motion unit, we'll be covering a new section called electricity, starting with what is electricity? So in order to understand the basics of electricity, it helps us a lot to first understand about atoms. So atoms are small particles that make up all matter. They are so small that it takes billions and billions of them just to make something useful like a pencil. Inside the atom are even smaller objects called protons, electrons, protons, and neurons. Electrons have a negative charge and the protons have a positive charge. The protons and neutrons stick together in the center of the atom called the nucleus. The electrons spin fast around the outside, and the positive charge of the protons keep the electrons from flying off and leaving the atom. So the electrons in the atoms are where electricity gets its name. In some elements, there are electrons on the outside of the atom that, when a force is applied, can come loose and move to another atom. So in this diagram to the right, we see our happy little proton and neuron snuggling at the nucleus, and the third wheelers, the electrons are circling around the nucleus. And when the force is applied, we see the electrons moving on to the next atom over. So when a bunch of atoms are together and electrons are moving from one atom to the other in the same direction, this is called electricity or an electric current. Electricity is what we call the flow of electrons.
Yeah, I guess I'm just gonna read this slide then. How do we make electrons move to make electricity? We take electricity by creating an electric circuit. Let's take the case where you are turning on a light in your house. When you flip the switch on, you're completing the electric circuit and causing electricity and electrons to flow through the light bulb. That causes the light to turn on.
So the basics to a circuit. So there are 4 components to a basic circuit: a power source, a conductor, load, and a switch. So the fundamental unit of a circuit will be the power source, which is where the power comes from. So this could be like a battery or a wall outlet. And the conductors are any piece of metal that basically can carry electricity from point 1 to point 2. So that could be like a wire, or really could be like just a metal. A load is something that the electricity will power. That can be a light bulb or like a microwave, or like also like your iPhone when you charge it. And a switch is something that can, turns it on. So your lights in a house are not always on because you have a switch that's open. When you close the switch, the circuit will complete and your light will turn on. So there's 2 types of metal / material. One is conductors and the other is insulators. So the difference is pretty significant. Like conductors is basically, like electrons can easily pass through. Basically, it's any type of metal, and it can easily give and take electrons. And electrons are typically evenly distributed inside. So for example, you have a sphere, then there'll be a really even distribution of electrons. However, for insulators, it's really tough for electrons to move through. So like, let's say like a piece of glass, like electrons will not be able to flow through it. And basically anything non-metal like rubber, plastic, your wall is insulated. And basically the reason why they're insulated is because they don't really give or take electrons. It's really hard for them to do that. So when they actually do accept electrons, they're always clumped in one area. So unlike conductors, they are like clumped in one area and they're not evenly distributed. And just a slight warning, do not touch your wall outlet because it can be very dangerous. We will explain why in like a later lecture. And we will explain what shorting a circuit is. Do not do that. We'll also explain that later. And also only use a circuit with proper instructions or surveillance, or like people watching you, because stuff can easily blow up or like start smoking, and it can be really dangerous to inhale or like be next to it.
And here we have an additional video just to recap what we've gone over today.
Electricity is all around us, and most of us use it every day. But do you really know what electricity is? To really understand electricity, you first have to start with an atom. Everything in the universe is made up of atoms. Let's look at this ant. We think of ants as being pretty small, but atoms are smaller, much, much smaller. Atoms are so small, in fact, that one ant is made up of too many atoms to count, more than 1 billion. If you take an object and keep breaking it down to smaller units, eventually you'll be left with only atoms, which we can call the building blocks of everything. Atoms have a couple of different parts, and a really important part of an atom is called an electron. Not all atoms have the same number of electrons. The number of electrons in an atom can change because electrons can move between atoms. Electricity is the movement, or flow of electrons from one atom to another. This flow of electrons is called current, electric current. Electrons can move in all materials, but they can move through some materials better than others. If electrons can move quickly and easily in a material, then that material is a conductor. A conductor is anything that allows electric current to flow from one point to another. The opposite of a conductor is an insulator. An insulator is a material that does not let electrons move well and doesn't conduct electricity. Have you ever seen the inside of a wire? The inside is usually made up of copper or another conductive metal, while the outside is made of plastic, an insulator. The copper wire helps the electrons flow, while the plastic insulator helps keep the electricity from being wasted and prevents us from being shocked. To use electric current to power things, you have to create a complete pathway for the electric current to follow. This is called an electric circuit. An electric circuit is like a racetrack of conductive materials that let the electrons flow in a specific way. For example, let's try to light a light bulb. First, you need a power source, like a battery. Next, you need to connect wires to the battery, and finally, the light bulb. Presto! Just like that, the circuit has been completed and the light bulb lights up. To learn more about electricity and circuits, explore the Curiosity Machine.
Oops.
Electricity is all.
Okay, and once again, sometimes physics can be difficult, and so if you ever get stuck on any concept or problem, you should go over the recording of the session. And if you have any further questions, fill out this Google form below, and we will try to answer all of your questions at the beginning of our future lectures. And this is one last meme for the day, for the week.
Hi everyone, welcome back to chemistry. Today we'll be talking about acid-base titration. So what is acid-base titration? An acid-base titration is used to determine the volume of a solution that is needed to react with a given amount of another substance. In an acid-base titration lab, we usually classify acids as Arrhenius acids and bases as Arrhenius bases. Arrhenius acids are compounds that dissociate when added to water, which will result in free hydrogen ions in the water. Arrhenius bases dissociate when added to water as well, but these compounds result in free hydroxide ions in the water. In order to make molecules of water, free hydrogen ions and hydroxide ions will combine, which is known as neutralization. When an acid and a base combine, they produce an aqueous solution with a dissolved salt made up of the cation from the base and the anion from the acid. One example of this is the combination of HCl and NaOH, which will yield an aqueous solution of sodium chloride, as you can see the equation below. And yeah, that is it. Thank you very much for attending.